Welcome to the deep dive. I want you to imagine, just for a second, treating a single, completely unremarkable pot of dirt on your front porch with the exact same rigorous analytical framework that you'd use to, I don't know, debug complex computer software.
Right, or like conducting a multi-million-dollar laboratory experiment.
Exactly. And that is precisely the mission we are taking on today. We are exploring this fascinating microdrama of backyard botany and really the art of everyday deduction.
It's such a great topic.
It really is. And our source material today is incredibly focused. We are looking at a single, meticulously documented entry that was published on June 23, 2026. The author goes by the name Ang, and the post is titled Notes on Gardening, Part 934, Observations on Floss Flower, which is also known as Ageratum, Seeds, Germination, Experimentation.
I mean, honestly, the title alone gives you this profound sense of scale before you even read the first sentence, Part 934.
Yeah, it's a lot of notes.
It is. This isn't just some fleeting thought or a random, weekend hobby update. This indicates a massive, sustained architecture of observation.
Right. When someone is on their 934th documented entry, you just know you are stepping into a deeply entrenched system of trial, error, and analysis.
Okay, let's unpack this. Ang presents us with a very specific, hyper-localized situation. There's a new cot, it is filled with fresh soil, and a seed has sprouted.
Yeah.
But rather than just shrugging and saying, hey, a plant is growing, Ang approaches this tiny green speck like a programmer, isolating a bug in millions of lines of code.
Oh, that's a great way to put it.
Yeah, like the environment is the operating system,
Right.
and this new sprout is basically a piece of rogue data that needs to be verified.
Which is an excellent way to frame it because Ang's post is fundamentally about the scientific method operating out in the wild.
Yeah, totally.
We have this cultural tendency to quarantine the scientific method, right?
Right.
To lock it away inside sterilized laboratories with white coats and sterile equipment.
Right, like it only happens in a pristine environment. Exactly. But the scientific method isn't a location, and it's not a set of tools. It is a cognitive framework. It is a highly specific way of processing reality, moving deliberately from hypothesis to observation to validation.
And Ang just takes that heavy, rigorous cognitive framework and applies it to a pot of dirt on a random Tuesday.
Exactly.
So let's get right into the mechanics of Ang's setup. Ang has this brand new gardening pot. It is filled with completely fresh soil. And into this fresh soil, Ang has placed a spent floss flower, the Ageratum species. So time passes and new sprouts emerge in the pot. Ang looks at the proximity of those new sprouts to the spent flower and makes an initial hypothesis.
Which is that the seed germination worked. The floss flower has reproduced.
Oh, right. But I have to push back on the foundational logic of that setup. I mean, if it's a fresh soil, doesn't that act like a blank canvas?
Oh, absolutely. It's unoccupied territory.
Yeah, because nature is incredibly messy and deeply opportunistic. How do we actually know a random gust of wind didn't carry a seed from a neighbor's yard?
Or bald.
Exactly. How do we know a bird didn't drop a completely different seed right into that fertile, unoccupied soil? Assuming the sprout is the floss flower, just because it's nearby, seems like, I don't know, a massive logical leap.
What's fascinating here is that Ang actually shares that exact skepticism.
Wait, really?
Yes, and that shared doubt is the mechanism that elevates this from a simple gardening diary to a masterclass in critical thinking. You are totally right to point out that fresh soil is essentially an open invitation to the local ecosystem.
Because the environment is totally uncontrolled.
Right, and despite the seemingly strong circumstantial evidence, the intentional placement of the spent flower, the new pot, the immediate proximity of the sprout saying explicitly writes, I'm not entirely sure that these are the seedlings of floss flower.
Which is just an incredibly difficult thing for the human brain to do in real time.
Oh, for sure.
Like, if you perform an action expecting a result, and a result appears, you naturally want to close the loop. You put a flower in the dirt, a green thing grows, the brain says mission accomplished.
Yeah.
Why is it so hard to maintain that level of doubt?
Well, because maintaining doubt burns cognitive calories. Neurologically speaking, the human brain is an energy-saving device.
It's just trying to be efficient.
Highly efficient. It is hardwired to seek out patterns and confirm its own biases as quickly as possible to reduce cognitive load. This is known as the confirmation bias loop. If you want to grow a floss flower and something green pops up in the exact location you designated for a floss flower, your brain aggressively wants to categorize that visual data as a success.
It wants to shut down the analytical process because analysis requires too much energy.
Precisely. Ang is actively resisting biology here. By holding space for doubt, Ang refuses to let the brain's desire for closure override the reality of an open, messy biological system.
So recognizing that the soil itself cannot provide a definitive answer, the investigation has to abandon the environment and focus entirely on the organism.
The physical evidence itself.
Exactly. This is where Ang starts looking really closely at the leaves of these new seedlings. And a major complicating variable emerges. According to Ang, the initial shape of these new leaves looks remarkably similar to basil.
Which is a completely plausible alternative reality.
Oh, yeah.
Yeah, I mean, basil is ubiquitous. It propagates easily. Given the chaotic nature of an outdoor environment that you mentioned earlier, the wind, the birds, insects, a basil seed finding its way into a hospitable pot of fresh soil is highly probable.
Here's where it gets really interesting. Ang does not just accept the macro impression of, oh, it looks like basil.
No, Ang leans in.
Yeah, Ang performs a highly granular inspection of these tiny new leaves and isolates a crucial botanical discrepancy.
The shape of the tips.
Exactly. The leaves of these new sprouts are pointed at the ends, and typical basil leaves, as Ang notes, have a rounded shape. It really makes me think of facial recognition software parsing through thousands of data points.
Oh, that's an interesting comparison.
Right. Like you might look at someone from across the street and think, oh, that's my friend. The height matches, the hair matches, the posture is identical. The macro impression is a 99% match.
Sure.
But the software flags a discrepancy in the biometric distance between the pupils. It's a millimeter difference, but it completely invalidates the initial match.
Right.
My question is, why wouldn't a gardener just look at the overall shape, register it as basil, and pull it out as a weed? Why go to the trouble of zooming in on the geometry of the leaf tips?
Because that is the mechanical difference between heuristic processing and active observation. Most of the time, we navigate the visual world heuristically.
Using mental shortcuts.
Exactly. Heuristics are essentially mental shortcuts. When we look at a garden, we don't process every individual vein on every single leaf.
We'd be exhausted.
We would. So we absorb general shapes, colors, and textures, and our brain quickly files them into known categories to save time. We see a slightly curved, vibrant green leaf. The brain accesses the basil file, and we stop thinking.
So active observation, which is what Ang is deploying here, requires you to intentionally break that heuristic process.
Yes. You have to force your brain to ask, does every single micro data point fully align with the macro assumption?
And the pointed ends of the leaves provide the friction that stops the assumption in its tracks.
It is the linchpin of the entire deduction. The pointed tip versus the rounded tip isn't just a fun piece of trivia, it is a morphological, biological signature.
Wow.
It is the data point that fundamentally shifts the hypothesis. Ang realizes that a macro impression can be easily faked by nature, but the specific granular geometry of the plant's development cannot.
So Ang isn't just watching the plant grow.
No, Ang is interrogating the physical structure of the plant to force it to reveal its true identity.
Okay, so the physical evidence is super compelling. The pointed leaves strongly suggest we are not dealing with basil.
Right.
But if we are treating this with true scientific rigor, proving that a leaf is pointed doesn't automatically prove it is a floss flower. It just proves it's not typical basil. To make this an airtight conclusion, Ang needs to address the circumstantial evidence of the surrounding environment. If we go back to the debugging analogy, you don't just fix the line of code. You have to prove that the error can't be originating from somewhere else in the system.
Which requires a significant shift in perspective. You have to pull the camera back.
Yeah.
You have to move from the microbiology of a single leaf tip to the macroecology of the entire front yard.
And that is exactly the pivot Ang makes. Ang systematically surveys the immediate environment, basically expanding the search perimeter to the entire front yard area.
Looking for clues.
Right. The goal is to track down any potential source code for the basil anomaly. And the environmental data Ang collects is definitive. There is absolutely no mature basil with spent flowers located anywhere around the front yard. Zero.
Not at all.
There is no local generator for basil seeds.
Let's look at the mechanics of why that specific observation is so powerful. In scientific inquiry, proving a negative, proving that something does not exist is notoriously difficult.
Oh yeah, definitely.
Yeah. But in a localized suburban ecosystem, establishing the absence of a parent plant drastically alters the statistical probability of a specific outcome.
Because you cannot have a basil sprout without a basil seed.
Exactly. While wind and birds are vectors, the most mathematically likely source for a seed is immediate proximity to a mature flowering plant. By confirming the total absence of mature basil in the yard, Ang essentially severs the most logical supply chain for that particular suspect.
So what does this all mean? It means Ang has systematically dismantled the alternative hypothesis.
Through a relentless process of elimination.
Yes. The geometry of the leaves overriding the heuristic assumption of basil, combined with the ecological survey proving no mature basil exists in the vicinity to provide seeds, the basil theory completely collapses.
The anomaly is resolved.
Right. And by eliminating the most likely alternative, the data heavily reinforces the original intent. The sprouts are, in fact, Floss flowers.
If we connect this to the bigger picture, the identification of the seedling is actually the secondary victory here.
Wait, really? The primary victory is what, then?
The primary victory is the validation of a methodology.
Okay, I need you to expand on that. How does looking at a leaf validate a methodology?
Well, think back to the catalyst of this entire scenario. Ang did not open a commercially packaged, pre-verified packet of seeds and pour them into the soil.
Right. Ang used a spent flower.
Exactly. Ang executed a deliberate technique, harvesting a spent floss flower and utilizing it to trigger germination. That is a proactive, applied methodology for interacting with a biological life cycle.
So if those sprouts had turned out to be basil or any other random weed, it wouldn't just mean the plant identification was wrong.
No, it would mean the methodology itself had failed. It would mean the attempt to harness the floss flower's reproductive cycle didn't work.
Oh, wow. I didn't think about it like that.
By scientifically ruling out the alternatives and confirming the presence of the floss flower, Ang transforms a localized anecdote. You know, I put a flower in dirt and something grew into verified, replicable data.
It proves that Ang's specific technique for capturing and germinating this exact species is fundamentally sound.
Exactly. It elevates the gardener from a passive observer of nature to an active, successful participant in its mechanics.
That is a massive paradigm shift for a backyard project. It turns a hobby into applied biology. You are no longer just hoping for a good outcome.
You are engineering a system.
And successfully debugging it when anomalies appear. But even with all of that logic stacked up, the leaf geometry, the ecological survey, the validated methodology, Ang throws one last curveball at the end of the entry.
The final concession to the reality of the scientific process.
Right. Ang concludes the entry, signing off as yours truly, Ang. But right before that sign-off, Ang writes, "We will likely have to wait for about one more week before we can be certain that these are indeed Floss Flower seedlings."
Incredible restraint.
Yeah, and Ang promises to revisit this in the coming weeks then. After all of that meticulous deduction, after basically proving the case beyond a reasonable doubt, Ang still refuses to close the file.
Because Ang understands that deduction is not the same thing as final maturity. It demonstrates a profound level of intellectual humility. We discussed earlier how the human brain craves immediate closure.
Right, we want to just say mission accomplished and move on.
Exactly. Even after running a rigorous analytical process, the temptation to declare absolute certainty is overwhelming. But Ang recognizes that these are still early-stage results.
The seedlings are in their infancy.
Yes, they have not yet developed their true, mature leaves, nor have they flowered. The biological system has to run its full course before the final, undeniable data can be harvested.
It's the equivalent of a software developer running a patch in a simulated environment, seeing that it works perfectly, but still refusing to push it to the live server until it has been stress-tested for another week.
That's a perfect analogy. You trust the logic, but you verify with time.
Yeah.
And this raises an important question, especially for you listening right now.
Oh, absolutely.
We exist in an information ecosystem that places a massive premium on instant gratification and absolute certainty.
We really do.
The moment we form a hypothesis or recognize a pattern, the cultural impulse is to immediately broadcast it as an established fact. We want the search engine to validate our thoughts in milliseconds. We want our projects to yield definitive results overnight.
It's exhausting.
It is. But when you look at how you approach your own complex problems, your own projects, or your own deeply held assumptions, how often do you actively engineer a pause?
Like genuinely stepping back.
Exactly. How often do you give your ideas an extra week to germinate, to fully reveal their true shape, before declaring them a success?
That is the ultimate takeaway here, the discipline to delay gratification in the service of accuracy.
Yeah.
Ang isn't just teaching us how to identify a plant. Ang is modeling a cognitive rhythm that most of us have completely lost touch with. The willingness to say, the data strongly supports my conclusion, but I'm going to let time be the final judge.
It forces you to respect the timeline of the system you are observing,
Right.
rather than imposing your own internal impatience onto it. Time is the one variable you cannot manipulate, and Eng leverages it perfectly.
It fundamentally rewires how you interact with your immediate surroundings. You start to realize that profound logical frameworks aren't just operating in textbooks, they're literally growing in the dirt on a front porch.
It's beautiful, really.
It is. And I want to leave you with this final thought to chew on. Notes on Gardening, Part 934, represents the meticulous documentation of just one tiny seed in a single pot on a random Tuesday in June of 2026.
Just one.
If a microdrama of this mechanical depth, this intense level of hypothesis, cognitive friction, morphological analysis, and disciplined patience is taking place in just one small container, consider the sheer scale of the invisible world around us.
Oh, wow.
What vast, entirely undocumented ecosystems of trial, error, deduction, and quiet triumph are playing out in the millions of front yards, windowsills, and garden beds we walk past every single day without a second glance. Every patch of soil is a complex biological puzzle. Every new sprout is a piece of rogue data waiting for someone willing to stop, override their own assumptions, look closely at the edges of a leaf, and ask the right questions.